Hey everyone, today we will have a look at Insertion Sort. I start by giving you a general overview of the way Insertion Sort works, then I will walk you through a small example, and if you're still there in the end, I will also go over the time and space complexity and give you some further information. The idea of Insertion Sort is simple. Like the name suggests, the algorithm works by inserting new elements into an already sorted array. This is achieved by caching the first unsorted element and then comparing it to the element on its left. If the left element is bigger, you move it one place to the right and continue to compare the cached element with the next element. If the left element is smaller or equal to the element you want to insert, or you have reached the start of your array, you can place the cached element into the empty place. Afterwards, you would start over by repeating these steps with the first unsorted element. To understand this better, we will have to look at an example. In this case, we start by comparing the 8 and the 6. I hope you all agree that the 8 is bigger, so let's move on to the next one. Here we want to insert the 4, which is smaller than the 8, so the 8 can steal its place, and after comparing the 4 and the 6 can follow our 8 and the 4 can take the place at the front, since there's no one left to contest it. After inserting the 4, we have to increase our I again and repeat this process all over. I guess the general idea should be clear by now, and since no one wants me to talk you through the rest of those steps, I'm going to speed the video up to show you how it would be done. Welcome back. If you tried it yourself, I hope you got it right. But now let's go on with the time and space complexity. If you look at this pseudocode, you see that there's a loop which is nested inside another one, and this already tells us that the runtime is going to be bad. In the worst case, you will need n times n minus 1 divided by 2 comparisons, so the total time complexity comes down to O of n squared. But hey, not everything about this algorithm is bad. We never changed the relative order of equal elements or had to use more than one extra space to store elements, which tells us that the algorithm is stable and in place. So what have you learned in this video? Insertion sort is definitely not the Usain Bolt of sorting algorithms, but it is stable, in place, easy to implement, and even though it has the same time complexity as bubble sort, Insertion Sort will find the solution a lot faster for most cases. As always, you can find the link to a Java implementation in the description below, and if you want me to make a video on calculating the time complexity, just leave a comment and I'll do my best. That's it for today, thank you for watching and until next time.